First grade, lesson 2 is called Put Together. The objective for this lesson is to be able to solve addition problems involving situations of putting two parts together. The important vocab you'll see this lesson is parts, whole, and equation. The kind of questions we'll be going over are using cubes to show 4 plus 2 and 2 plus 4. So that leads into the commutative property. We're starting off with a bridge from kindergarten visuals to math sentences that they're learning in first grade, learning that the parts that you're adding together come together to make the whole. The higher order thinking questions they have are adding together multiple categories and then only recognizing the important information, and writing their own story, drawing pictures to write an equation. The assessment practice problem we will end on is a multiple choice question that brings everything we've talked about together. Starting off for the put together lesson, we've got kindergarten visuals. This is stuff they've learned in the past. They were given 4 red fish and 2 blue fish and asked how many fish in all. We're bridging that now to what they're learning in first grade. Remember that vocab parts is what we want to really drill, that the two parts are what they're given, and when we add those parts together, we get the whole. We're bridging from kindergarten to first grade, so instead of having these helpful visuals, we're changing them to cubes. Cubes are something they might have available to these students in the classroom, a hands-on way for them to add things together without literally having the object that's being talked about in the word problem. So the parts in this word problem, 4 red fish and 2 blue fish, the parts are 4 and 2 because the question is asking how many fish are there in all. In all means we're going to add together the two parts to get the whole. They've already filled in the 4 and the 2 for your student, but it's good to get them tracing and used to writing in those numbers. The lesson then moves into showing these blocks as an addition problem. So the two parts get added together. Again, it's just a good chance for your students to trace and practice writing in those numbers. The whole is when we bring these two parts together. So when we add parts, we find the whole. Another word you'll see in this lesson is sum, and they'll see that from first grade all through the rest of their math career. The word sum means the answer to an addition problem. So when they see whole, they can think sum. And if they see the word sum, I want them to think whole. When we add parts together, that's what makes the whole. This whole lesson comes together at the end with the students being able to write an equation. Again, they've already filled in the numbers for the students. The parts are 4 and 2. That's what we are adding together to get the sum. So what does it equal to add two parts together? This equals 6. And in the word equation, we almost have the word equal. So in order to have a successful equation, your student needs to have written an equal sign in their equation. This means that when we've added 4 plus 2, 6 is the whole, 6 is the sum, and there are 6 fish in all. They want the students to work out showing 4 plus 2, but then also showing 2 plus 4. So this is just taking everything they did one step further by using cubes. So your student still has that visual, but they're creating the visual themselves. So to show 4 plus 2, we've got almost the same visual they've already given them, so they can just copy what they've seen. But then they have to take it one step further and go, okay, what if I started with 2 first and then added 4? And the student here should recognize that either way they add that, they're going to get 6 as an answer. This in the future will be known as the commutative property. This property works for addition and multiplication, and it just says that if you add two numbers and then add them the opposite way, you will still get the same answer. Same thing with multiplication in the future. 4 times 2 would be the same as 2 times 4. That's the commutative property. And it's not a word they're going to be learning in first grade, but this is just introducing that idea so that when they see it in the future, it's not the first time they've seen it. Now moving on to the main part of the practice, number 1 starts with 3 yellow birds and 5 blue birds. How many birds are there in all? Again, they've already given the student the example filled in. Your student should take the time to practice tracing these, and then have them verify that if they could add 3 and 5. They might want to sit there and count these birds, 1, 2, 3, 4, 5, 6, 7, 8. Point out to your student that these are the parts, and this is the whole or the sum. Your student might also recognize that it's easier to count from the 5 birds, so they'll start with the number 5 and then count up 6, 7, 8. That's the easier way to do this problem. Start with the larger number so you have less work to do. Some students will count each bird individually. Others will start with 3 and then count up from there. All right, number 2 says we have 1 white egg and 6 blue eggs. How many eggs are there in all? This is the first time your student's going to have to recognize what are the parts, what is the whole, and what does an equation look like. The parts in this case are what they've given you, 1 and 6. Those are the parts. And those go on this side of an equation. Since this is asking in all, your student should recognize that this is an addition equation. And since this lesson is talking about parts and the whole, we have an equation to write. When you add 2 parts together, you will get the sum. And now we can fill in those parts. So we have 1 part and 6, 1 white egg and the 6 blue eggs. Now we have to count. I like to start with the bigger number, 6, 7. So our whole or the sum is 7. In number 3, it's the same as number 2. Your student is in charge of recognizing what are the parts and how can I write this as an equation to figure out how many pigs there are in all. Equation means there's going to be an equal sign. The word equation almost has the word equal in it. So we're going to say these 2 parts, if I add them together, will tell me how many pigs there are in all. The parts are the 3 little pigs and the 4 big pigs. The size doesn't matter. They are just asking for how many pigs there are in all. And the total would be 3 plus 4. 3, 4, 5, 6, 7. Or your student might start with 4 and add 3. They might even count all the pigs individually. And the advanced thinking for this one is if your student knows their doubles facts, they can do 3 plus 3 plus 1 more, because 4 is just 1 more than 3, to know that the double fact 6 plus 1 more would be the same as 3 plus 4, giving us the 7 pigs. In number 4, we have 3 boxcars and 3 tank cars. So the parts are 3 and 3. They're asking how many cars are there in all, and the student is asked to write an equation. They're just filling in boxes here. So our parts are 3 and 3. This is an addition problem because we're asked to find in all. We want to find that whole or the sum, which means 3 plus 3 is equal to, making an equation that we've written. 3 plus 3 is 6. This is a doubles fact that they should have in their back pocket, ready to go. For this lesson, this is our first higher order thinking question. The information we're given is that there are 2 red hats, 3 shoes, and 7 blue hats. The question is asking how many hats in all. So again, we're looking for the sum. We're trying to find the whole. And the parts we're given are 2 red hats, 3 shoes, and 7 blue hats. They are asking how many hats there are in all. So the student needs to recognize that the numbers aren't all that they should be paying attention to. We need to pay attention to the words telling us what represents hats. There are 2 red hats and 7 blue hats. That's all we need to be thinking about. So those are the only parts that matter. The parts get put into our equation, 2 and 7. We want to draw a picture for this one. There are 2 red hats, and then there are 7 blue hats. Make it fun. Your student could draw whatever kind of hat they'd like. Party hats, baseball hats, whatever they'd like to draw. I'm going with top hats. It's easy to draw, easy shapes. That might help us tactily counting out what the answer to this equation is going to be. Because it says in all, I'm adding these parts together, and the whole is going to be 7 and 2 more, 7, 8, 9. I like to start with the larger number. We drew a picture, we wrote an addition equation. We know that because we have the equal sign, and we're set. Okay, for number 6, Jen has 2 red flowers and 5 blue flowers. How many flowers are there in all? So again, we're looking for the whole or the sum when it asks in all. These are key words your student should associate with finding the sum or finding the whole, knowing that this is an addition problem. The parts are 2 red flowers and 5 blue flowers. Their job is to write an equation, and it points out that you could use cubes or draw a picture because a lot of students enjoy drawing and incorporating that part of their skill set to make this a little more fun. They could draw 2 red flowers and 5 blue flowers, and now they can take that and write it in as an equation. There are the 2 red flowers, 5 blue flowers. Because we're looking for in all, it is an addition equation. Because it's an equation, we have an equal sign. And now we can count the flowers. Your student might have done that while they were drawing. 1, 2, 3, 4, 5, 6, 7. My go-to is look for the bigger number and count on from that. So we don't have to start at 1. We can start at 5 and go 6, 7. Students also just might like to go in order with what they're given and start at 2 and then 3, 4, 5, 6, 7. It doesn't matter how they get there. There are lots of creative ways to do this. I find that the quickest one is adding on from the larger number to get us that 7 flowers. Number 7 is another higher order thinking question. So just having them take this skill and push it one step further. This is a really creative higher order thinking question. They want the students to write a picture story. So they want the students to draw a picture for the story they're given. They can add other elements. They can make this as fun as they'd like to or as simple as they'd like to. We need to show blue fish and green fish. The student gets to come up with how many blue fish and green fish there are here. It really could be as simple as them drawing 1 blue fish and 1 green fish. But I would really encourage your student to push themselves here. Have them draw a picture, have them come up with a story, name the fish, however many they'd like. Once they have that story and whatever amounts they chose, they need to identify what are the parts, what does that equation look like, and how many fish do they have in all. Everybody's answer could look different for this. In my case, I've got 3 fish and 5 fish. And because it's asking in all, I know this is an addition equation, and the whole or the total or the sum of how many fish there are is 5 and 3, which is 8 fish. That might not be the case for your student's story. We're finishing out this practice with an assessment practice problem. Most student practice pages have these assessment practice problems. When you see that, it is likely that this will be at the end of unit assessment. So since we're in topic 1, when your student takes the topic 1 assessment, they will have a question that's very similar to this question. This is a multiple choice. They're given several different options for what the equation could look like. They're going to choose the correct equation that shows these parts being added together to get how many apples there are in all. Now, there are 4 red apples and 5 green apples. So if we added these together, because we're looking for in all, we're looking for a sum. This is a part, this is a part. So I'm looking for, in the answer choices, the parts to be 4 and 5. And I don't necessarily need to add these together. It's great practice. But when we're learning how to take a multiple choice test, the parts I know are already 4 and 5. So I'm looking for the question that has that element to it, and then I can double check what is the whole. I only see one answer choice that has 4 and 5 as the parts being added together. The other ones don't. So even though there are 9 apples in 2 separate answer choices, if your student went straight to just finding the answer and not thinking about what are the parts and what are the wholes, it's very likely they chose the wrong one. I always encourage students to write the equation off to the side or write the answer off to the side to make sure that their answer exactly matches what they've chosen so they don't make those small mistakes. What's nice about multiple choice is you know that the correct answer is already on the page. You just have to get your thinking to match that. So if the parts are 4 and 5 that we're adding together, what is that equal to if we count all of these? Again, we could do doubles plus 1. If your student knew 4 plus 4 is 8, we're just adding 1 more because 5 is 1 more than 4. We could also count on from the larger number. 5 plus 4 is 9. 8 plus 1 is 9. There are many ways to get to this answer. They could have counted in the beginning and found 9 and narrowed down that this only has 2 possible correct answers. Now we're just looking for what is the accurate part and what is the accurate whole. And that's it for the topic 1, lesson 2 practice for the put together lesson. If you found this video helpful, give it a thumbs up and don't forget to subscribe. We'll be breaking down math concepts to help you support your child with confidence. Leave a comment letting me know what you'd like to get help with next. If you'd like to support the channel and get access to exclusive resources, check out our Patreon. Every little bit helps to keep creating helpful content for people just like you. Thank you so much for watching. I'll see you next time.